Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice Paper 12 from February-March 2021. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. The table shows the number of protons, neutrons and electrons in 4 different particles W, X, Y and Z. Which pair represents the atoms of 2 isotopes of the same element? Now for isotopes, we know that isotopes are the atoms of the same element having same number of protons but different number of neutrons. So protons should be same. It could be W, X and Y. Neutrons should be different, so it could be either W and Y or X and Y. Third thing is the number of electrons. Now number of electrons indicate whether the atom is neutral, positive or negative. In W, the number of protons is equal to the number of neutrons, so therefore this is neutral atom or neutral isotopic atom. In X, the number of protons is 32 while the number of electrons is 34. It means the charge is -2, so it is negative ion. In Y, number of protons is 32, number of electrons is again 32, so it is also neutral atom. In the question it says which pair represents the atoms. It does not say about ion, so therefore it is not X, it could be W and Y. Correct answer is therefore A. Question 2. Where in the periodic table is the element that has an outer electron shell arrangement of 4s2, 4p3? We have to find its group number and period number. Now from this information 4s2, 4p3, we can find out both the period number and the group number. This is principal quantum number. It represents the period number. So we have 4th period in which this element is present. So this element has 4 electronic shells. In 4th shell we have 2 electrons in S and 3 electrons in P. So total number of electrons in 4th shell or the valence shell is 3 plus 2, which becomes 5 electrons. Now if there are 5 electrons in the valence shell, it means it belongs to group 5th in the periodic table. 5th group is also called group 15. Correct answer is therefore D. Question 3. Substance Q is a hydrocarbon. When 1 grams of Q is completely burned, 3.22 grams of carbon dioxide is produced. What could be the identity of Q? Now let's find the formula and molecular mass of these given compounds. First one is cyclohexene. In cyclohexene we have 6 carbon atoms in ring structure. Also one double bond is present as it is alkene. Rest are the number of hydrogen atoms. In double bonded carbon we just have 1 hydrogen atom each. So the formula is C6H10. And the molecular mass is, we have 6 carbon atoms, so 12 into 6, which is 72. Plus we have 10 hydrogen, so it is 82. Similarly, we can find the number of moles. Mass in grams is given, so as moles is equal to mass in grams divided by molecular mass. So it is 1 divided by 82. It comes equal to 0.0122 moles. So we can write molecular mass 82 and number of moles as 0.0122 moles. Similarly, B is cyclopentane. Pentane means we have 5 carbon atoms and it is alkane. All carbon-carbon bonds should be single. Each carbon atom is making 4 bonds, so we have 2 hydrogen atoms with each carbon. Now the molecular formula is C5H10. Molecular mass will be 12 into 5, which is 60, plus 10, it equals to 70. Now number of moles will be mass in grams, which is 1 gram divided by molecular mass, which is 70. So it is equal to 0.0143 moles. So we can write 70 as molecular mass and 0.0143 as number of moles. In part C, we have ethene. Ethene is an alkene consisting of 2 carbon atoms. The formula is C2H4. Molecular mass is 24 plus 4, which is 28. Number of moles will be 1 divided by 28. It is equal to 0.0357 moles. So molecular mass is 28. Number of moles is 0.0357 moles. Similarly for D, we have pentane. Pentane means 5 carbon alkane. The general formula of alkane is CnH2n plus 2. So hydrogen will become 12. Molecular mass is 60 plus 12, 72. Number of moles will be 1 grams divided by 72. It is equal to 0.0138 moles. So we can write 72 as molecular mass and 0.0138 moles. Let's find out the number of moles of carbon dioxide that is produced, and mass is given. The formula of carbon dioxide is CO2 and the molecular mass is 44. So number of moles of carbon dioxide will be mass in grams divided by molecular mass. Number of moles is equal to 0.073 moles. Now we can write the balanced equation for each of these given compounds, and the number of moles, whichever gives this number of moles of oxygen upon complete combustion, will be the correct answer. First one is cyclohexene. The formula is C6H10. Combustion equation is this one. We have CO2 and H2O that are produced. Let's balance. We have 6 carbon atoms on the reactant side, so it will be 6 CO2. Now there are 10 hydrogen atoms, so we can balance hydrogen by writing 5 with water. Again, we can balance oxygen atoms. Now balancing of oxygen and water is not needed because in question only CO2 and hydrocarbon ratio is given. So we can say that 1 mole of this hydrocarbon, it produces 6 moles of carbon dioxide according to the balanced chemical equation. So we can say that 0.0122 moles of this hydrocarbon will give X moles of CO2. Let's cross multiply and find the value of X. If X is equal to this much, then this would be the correct answer. By cross multiplying, we can write X is equal to 0.0122 into 6. So it comes equal to 0.073 moles of CO2 that is produced. As we can see that the number of moles are same, so therefore A could be the correct option. Similarly, we can do it for all of the other compounds. We have cyclopentane. In cyclopentane, the formula is C5H10. It forms CO2 and H2O. Again, we need only to balance carbon atoms, so it will be 5 CO2, so 1:5. As we have 0.0143 moles of hydrocarbon, so it will form X moles of CO2. By cross multiplying, we can find the number of moles of carbon dioxide that are formed by this compound. It comes equal to 0.0715 moles of CO2 that is produced. So this is not equal to this one, so therefore B is incorrect. Similarly for ethene, the formula is C2H4. This is the combustion equation. Let's balance number of carbon atoms. We have 2 carbon on the reactant side, so it will be 2 CO2. So 1 mole of this hydrocarbons produces 2 moles of CO2. So 0.0357 moles will produce X moles of CO2. Let's cross multiply. The number of moles come equal to 0.0714 moles of CO2 that is produced. This is not similar to this one, so therefore C is also wrong. Last one is pentane. Formula is C5H12. It combusts to form CO2 and H2O. Let's balance carbon atoms. We have 5 carbon atoms on the reactant side, so it will become 5 CO2. The number of moles in balanced equation is 1:5. Now we have 0.0138 moles of reactants. It will form X moles of CO2. By cross multiplying, the number of moles of carbon dioxide is 0.069 moles of CO2. As we can see that this is not similar to this one, so therefore D is also wrong. Correct answer is therefore A. Question 4. Originally, chemists thought indium oxide had the formula INO. By experiment, they showed that 4.8 grams of indium combined with 1 grams of oxygen to produce 5.8 grams of indium oxide. The atomic mass of oxygen was known to be 16, which value for the atomic mass of indium is calculated using these data. We can write the balanced chemical equation for the reaction of indium with oxygen. So we have In as indium. It reacts with oxygen to form INO. Let's balance this equation. We have 2 oxygen atoms, so we can write 2 with the product. Again, we can write 2 with IN to balance this one. Now the molar ratio according to balanced chemical equation is 2:1 for indium and oxygen. The mass of oxygen is given, it is 1 gram oxygen, so we can find the number of moles as moles is equal to mass in grams divided by molecular mass. Oxygen is O2, so its molecular mass is 32. The number of moles of oxygen come equal to 0.03125 moles. Now we can find the number of moles of indium by using these moles of oxygen. So 0.03125 moles of oxygen will need X moles of indium to form indium oxide. Now we can find the moles of X by cross multiplying. X is equal to 0.03125 into 2. It comes equal to 0.0625 moles of indium. Now we have mass in grams of indium and we also have number of moles of indium. So we can find the atomic mass by using formula as number of moles is equal to mass in grams divided by atomic mass. Or we can rearrange, atomic mass will be equal to mass in grams divided by number of moles. By putting values, we have 4.8 grams of indium and we also have 0.0625 moles of indium. Now relative atomic mass of indium comes equal to 76.8, or we can write 77. Correct answer is therefore B. Question 5. In which substance are only intermolecular forces temporary dipole-induced dipole attractions? Now you should remember that temporary dipole-induced dipole attractions are present only in non-polar molecules or compounds. A is hydrogen chloride. In hydrogen chloride, hydrogen and chlorine have quite a lot of electronegativity difference, due to which chlorine is partial negative, hydrogen is partial positive. So we have opposite poles that are present, so therefore permanent dipole forces will be present. A is incorrect. In B we have methanol. Methanol is an alcohol and its formula is CH3OH. Due to greater electronegativity of oxygen, it is partial negative and hydrogen will become partial positive. Again we can see that opposite poles are present, so therefore permanent dipole forces will be present in methanol. Third one is octane. Octane is an alkane having 8 carbon atoms and 18 hydrogen atoms. There is not much electronegatividity difference between carbon and hydrogen, so opposite poles are not present. So this is non-polar compound. Due to the absence of polarity, only temporary dipole-induced dipole attractions will be present, so it could be C. In D, we have water. The formula is H2O. We have 2 hydrogen, 1 oxygen. Again, oxygen is more electronegative, so it is partial negative. Hydrogen will be partial positive. Opposite poles are present, so water is polar. D is incorrect. Answer is therefore C. Question 6. A solution contains 0.25 grams of sulfur dioxide in 1 decimeter cube of water. Which volume of sulfur dioxide measured at 50 degrees centigrade and a pressure of 1 exponential 5 pascals must be added to 1 decimeter cube of water to produce this solution? So we have to find out the volume of this gas. We have temperature, pressure, volume and mass in grams as given values. So we can use ideal gas equation. We have PV is equal to nRT. For volume, we can rearrange. Volume will be equal to number of moles into ideal gas constant into temperature in Kelvin divided by pressure in pascals. As we don't have the number of moles, so therefore first we are going to find the number of moles from this given mass. The formula of sulfur dioxide is SO2. Molecular mass of sulfur is 32.1 and for 1 oxygen it is 16, so for 2 it will be 32. So in total the molecular mass is 64.1. Now we can find the number of moles. Moles is equal to mass in grams, which is 0.25 divided by molecular mass, which is 64.1. So it comes equal to 0.0039 moles. Now putting values in volume equation, we have volume in meter cube, which is equal to number of moles, 0.0039 moles, into ideal gas constant, which is 8.31, into temperature in Kelvin. We have 50 degrees centigrade, so we can convert it into Kelvin by adding 273. So it becomes 323 Kelvin. 323 divided by pressure. Pressure is already given in pascals, so it is 1 exponential 5. So volume in meter cube will be equal to 0.000105 meter cube. In the question, they have given volume in centimeter cube, so we can convert meter cube into centimeter cube by multiplying with 1 exponential 6. So it is equal to 105 centimeter cube. Correct answer is therefore D. Question 7. An experiment was performed to determine the enthalpy of combustion of ethanol. We have thermometer, test tube, water, spirit burner and ethanol that is combusted. The data collected are shown. We have mass of water, mass of ethanol, temperature rise, molar mass of ethanol and specific heat capacity of water, whose value is given. Which expression can be used to calculate the enthalpy of combustion of ethanol in kilojoules per mole? For finding out enthalpy change, we can use the formula delta H is equal to minus mc delta T, where delta H is the enthalpy change, m is the mass of water, which is W grams, C is the specific heat capacity of water, which is given as 4.2 joules per Kelvin per grams. Delta T is the change in temperature, which is given as Y. Now this is given in degree centigrade. There would be no effect if it was in Kelvin because temperature rise is always the same whether it is degree centigrade or Kelvin. So we can write Y Kelvin. Putting values in this equation, enthalpy change of combustion will be minus M. Instead of M we are going to write W. Instead of C we are going to write 4.2. joules per Kelvin per grams. W was given in grams. Change in temperature is going to be Kelvin, so we can write Y Kelvin. Now we can cut grams with per grams, per Kelvin with Kelvin, so we have minus W into 4.2 joules into Y. Now this shows the energy that is released by burning X grams of ethanol. But they have asked to find it in kilojoules per mole. Let's first convert this equation into kilojoules. We have joules, so we can divide it by 1000 to make it kilojoules. So delta H will be minus W into 4.2 into Y divided by 1000 kilojoules. So this shows enthalpy change of combustion in kilojoules for X grams of ethanol. Now we have to find it for moles, not for grams. So let's convert this grams into moles. The formula is number of moles is equal to mass in grams divided by molecular mass. So mass in grams is X, molecular mass is Z. So number of moles is X divided by Z. Now we can change this enthalpy change into moles by dividing with X by Z. So we can write delta H equals minus W 4.2 Y divided by 1000 divided by number of moles, which is X by Z. So now final equation will be delta H equals minus W 4.2 Y into Z divided by 1000 into X. This is the enthalpy change of combustion of ethanol in kilojoules per mole. Similar equation is given in A, so therefore A is correct answer. Question 8. VO2Cl reacts with sodium iodide under acidic conditions. This is the equation. The oxidation state of Cl is -1 in VO2Cl and in VOCl2. Which row about this reaction is correct? You have to find whether vanadium is oxidized or reduced and whether iodine is oxidized or reduced. Let's find the oxidation state of vanadium and iodine in the given compounds. We have VO2Cl. We also have VOCl2. We have VOSO4. To find the oxidation state of vanadium, we have to put the oxidation number of oxygen and chlorine. Oxygen is -2, so we have 2 oxygen, it will become -4. Chlorine is given, it is -1. Overall charge is 0. So we have V -5 equals 0 or vanadium equals +5. Similarly, in VOCl2 we have vanadium, then oxygen, then 2 chlorine atoms. Overall charge is 0, so vanadium will be equal to +4. So it is +4 in VOCl2. In VOSO4 we have sulfate. The charge on whole sulfate is -2. The charge on oxygen is also -2. So vanadium -2 for oxygen, -2 for sulfate equals overall charge, which is 0. So vanadium is equal to +4. So we can see that whenever oxidation state changes from +5 to +4, it is decreasing, so therefore vanadium is reduced. Now for iodine, we have sodium iodide. In sodium iodide, sodium is +1, iodide is -1. In iodine molecular form, the oxidation state of iodine is 0. So from -1 to 0 is called oxidation. So iodine is oxidized. Correct answer is therefore C. Question 9. In which reaction is water behaving as a Bronsted-Lowry base? Now Bronsted-Lowry base is proton acceptor. that accepts H+. Now they are asking about water. We have H2O. Whenever water accepts a proton, it forms H3O positive. Let's see which equation represents this change. We have H2O and there is no H3O, so therefore A is incorrect. In B we have H2O that converts into H3O positive. It means that water is behaving as Bronsted-Lowry base, so it could be correct one. In C we can see that H2O is not converted into H3O positive. Again in D we can see H2O is not converted into H3O positive. Correct answer is therefore B. Question 10. A large excess of marble chips is reacted with 25 cm3 of 1 mole per decimeter cube hydrochloric acid at 40 degrees centigrade. How is the result different when the reaction is repeated with 60 cm3 of 0.5 mole per decimeter cube hydrochloric acid at same temperature, which is 40 degrees centigrade? Now as the temperature given is similar in both, so therefore rate of reaction will depend on first thing, which is surface area. Larger surface area means faster chemical reaction, and second is concentration. Higher concentration means faster chemical reaction. We have marble chips, which is calcium carbonate. We have hydrochloric acid, which is HCl. The products are calcium chloride plus water plus carbon dioxide gas. In the question it says excess of marble chips is reacted, so therefore calcium carbonate is in excess, therefore HCl is the limiting reagent. Now volume and concentration of HCl is given in both, so we can find the number of moles in both reactions. In first reaction we can use the formula number of moles is equal to concentration into volume in decimeter cube. So concentration is given, it is 1. Volume is given, it is 25, so we can convert it into decimeter cube by dividing by 1000. So it comes equal to 0.025 moles. Similarly, we can find number of moles of HCl in second one. By using same formula, we have number of moles is equal to concentration, which is 0.5 mole per decimeter cube, into volume, which is 60. So converted into decimeter cube, we are going to divide by 1000. So number of moles come equal to 0.03 moles. Now as we can see, we have less concentration of HCl in second experiment as compared to the first one. So therefore now the reaction will be slower. So it is either C or D. Second thing is the amount of product, whether it is more or less, as the product depend on HCl because it is limiting reagent. So more moles of HCl will form more moles of products. So 0.03 moles will form more moles of products. So therefore more product is formed in the second reaction. Correct answer is therefore C. Question 11. The Boltzmann distribution curve for gaseous mixture of ethene and hydrogen is shown. Nickel is an effective catalyst for the reaction that occurs. How does the diagram appear if the same reaction mixture is at higher temperature? Now higher temperature increases the average kinetic energy of molecules. So now more molecules have activation energy to convert into products. As area under the curve always remains constant, so therefore the curve will be like this. Part A, the curve is unchanged. This is incorrect because temperature changes the shape of curve. Catalyst does not change the shape of curve. B, the values of both EA catalyzed and EA decrease. This is incorrect because temperature does not have any effect on activation energy. It just increases the average kinetic energy of the molecules. C. The values of both EA catalyzed and EA increase. Again, this is incorrect because temperature has nothing to do with activation energy. D. The values of both EA catalyzed and EA remains the same. This is true because we are only changing the temperature. Answer is therefore D. Question 12. Which observations are made when a sample of silicon chloride is added to a beaker of water? The chemical reaction is this. We have silicon tetrachloride. When it is added to water, it forms silicon dioxide along with fumes of HCl gas. Silicon dioxide is white precipitate. As it is insoluble in water, HCl is in the form of white fumes. A. No visible change is observed. This is incorrect. B. Steamy fumes and a precipitate are both observed. This is true statement. C. The appearance of a precipitate is the only observation. Now it is incorrect because HCl is also formed. D. The appearance of steamy fumes is the only observation. Again, this is incorrect. Answer is therefore B. Question 13. Which row is correct? We have statement and then we have reason. In the statement we can see phosphorus and magnesium is given. There are different properties that are discussed. Part A. The first ionization energy of phosphorus is greater than that of magnesium. Now magnesium and phosphorus both belong to period 3 of the periodic table, and magnesium is in group 2 while phosphorus is in group 5 of the periodic table. Now as we know that in the same period what happens when number of protons increase, ionization energy also increases. So the first ionization energy of phosphorus will be higher than that of magnesium. This is true. We can do the electronic configuration. The atomic number of magnesium is 12, phosphorus is 15. So for magnesium it is 1s2, 2s2, 2p, 6 and 3s2. While for phosphorus it is 1s2, 2s2, 2p6, 3s2 and 3p3. Now as proton number increases, the number of electrons also increase and the force of attraction between protons and outer electron also increases. So therefore ionization energy of phosphorus should be high as compared to magnesium. The reason given here is that electron is lost from a 3p orbital in both cases. Now first electron is lost from 3p in phosphorus, while for first ionization energy the first electron lost will be from 3s in magnesium. So therefore this is incorrect reason. Part B. The melting point of phosphorus is greater than that of magnesium. Now magnesium is in group 2 and it is a metal, while phosphorus is in group 5 and it is non-metal. Phosphorus exists in the form of a molecule of 4 atoms which is P4, so it is simple molecular. The melting point of phosphorus will be lower than that of magnesium because in magnesium metallic bond is present. So B is incorrect. C. The atomic radius of phosphorus is smaller than that of magnesium. Now moving along the period, the size of atom decreases. This is because number of shells remains same. In magnesium we have 3 shells. In phosphorus again we have 3 electronic shells. So as nuclear charge increases, the attraction between nucleus and outer electron increases. So therefore size will decrease. This is true statement. The reason given is that phosphorus has greater nuclear charge than magnesium. Now phosphorus has 15 protons while magnesium has 12. So this is a true reason. Part D. The electrical conductivity of phosphorus is smaller than that of magnesium. Again this is true statement because phosphorus is a non-metal while magnesium is a metal, and metal is a good conductor of electricity. Now the reason given is that the bonding changes from ionic in magnesium to covalent in phosphorus. Now magnesium has metallic bonding, it does not have ionic bonding, so therefore this reason is wrong. Correct answer is therefore C. Question 14. Which row correctly describes one property of barium and one property of barium oxide? First is the observation when barium metal is added to water. Second is the pH of solution obtained when a spatula measure of barium oxide is added to 100 cm³ of water. Now barium is a group 2 member, and as group 2 consists of all metals, the reactivity of group 2 increase from top to bottom. This is because number of shells increase and it is easier to lose electrons in the bottom as compared to the elements at the top. So when barium is added to water, it forms barium hydroxide along with hydrogen gas. We have a few bubbles form on the metal surface. Again, B is the same. In C, we can see rapid effervescence is seen. Now, as barium is more active, so therefore rapid effervescence is seen in this reaction. This is due to bubbles of hydrogen gas that is produced. Second is the pH of solution when barium oxide is added to water. Barium oxide is a highly soluble oxide. It dissolves in water to form base, which is barium hydroxide. Now barium hydroxide is highly soluble, so therefore it will form pH of 13. Correct answer is therefore D. Question 15. An anhydrous white salt Z is heated strongly for 30 minutes. A mixture of gases is given off. The solid remaining in the test tube is then dissolved in small volume of dilute hydrochloric acid. The addition of few drops of dilute sulfuric acid to the test tube causes a white precipitate to form. Which substance could be Z? The first thing is to heat it strongly to form gas. In A, we have barium carbonate. Barium carbonate, when it is heated at high temperature, it forms barium oxide, which is solid, along with CO2, which is gas. So as it says, a mixture of gases is given off, but we only have one gas, so therefore A is wrong. Same is the case with magnesium carbonate, because carbonate forms metal oxide, which is magnesium oxide, solid, along with CO2. Only one gas is produced, so this is wrong. Now we have barium nitrate and magnesium nitrate. Barium nitrate, when decomposed, it forms barium oxide, which is solid, nitrogen dioxide, which is gas, and also oxygen gas. So as mixture of gases is produced, so therefore nitrate could be the correct option. Similar is the case with magnesium nitrate. It will form magnesium oxide, nitrogen dioxide, and oxygen gas. So it could be from B or D. Now the question says that the solid remaining in test tube is then dissolved in dilute hydrochloric acid, and then few drops of sulfuric acid are added to make white precipitate. Now in barium nitrate, we had barium oxide that was present in test tube. In magnesium nitrate, we had magnesium oxide that was left in the test tube. So in the presence of HCl and H2SO4, it will form a precipitate of barium sulfate. Now barium sulfate is insoluble white salt. Second compound, that is barium chloride, is soluble, so therefore that is not needed. Similarly, in magnesium oxide, when it reacts with HCl and H2SO4, it will form a mixture of salts. One is magnesium chloride, second is magnesium sulfate. Both are soluble. So no white precipitate is formed in case of magnesium nitrate. So correct answer is B. Question 16. Chlorine gas is reacted with aqueous sodium hydroxide. The oxidation number of chlorine changes from 0 to -1 and also from 0 to +1. Under which conditions does this reaction occur, and what is the color of the solid silver salt with chlorine in the oxidation state -1? Let's write the reaction. We have two types of reaction. One is with cold dilute alkali. Second is with hot concentrated alkali. Now with cold dilute sodium hydroxide, the reaction will be like this. We have chlorine Cl2, sodium hydroxide, which is cold dilute. It will form sodium chloride, NaClO, and water. Now second reaction of chlorine is with hot concentrated alkali. Cl2 plus sodium hydroxide. It will form sodium chloride, NaCl, NaClO3 along with water. The oxidation state of chlorine in molecular form is 0. In NaCl it is -1. Let's find the oxidation state of chlorine in NaClO and NaClO3. We have one sodium, so it is +1, one chlorine, and one oxygen. Oxygen is -2, overall charge is 0. So chlorine -1 equals 0, chlorine equals +1. So the oxidation state of chlorine in NaClO is +1. In NaClO3 we have one sodium, one chlorine, and as there are 3 oxygens, so it is -6, overall charge is 0. Chlorine -5 equals 0, so chlorine will be +5. This is the oxidation state of Cl. As in the question it says it changes from 0 to -1 and 0 to +1, so therefore it means it is cold dilute alkali, not hot concentrated alkali. Now the color of silver salt with chlorine in the oxidation state -1. When chlorine is -1, the compound formed is AgCl, and AgCl is white precipitate. Correct answer is therefore A. Question 17. When concentrated sulfuric acid reacts with sodium iodide, the products include sulfur, iodine, hydrogen sulfide, and sulfur dioxide. Which statement is correct? Let's write the chemical equation. We have sulfuric acid. It reacts with sodium iodide to form sulfur, iodine, hydrogen sulfide, and sulfur dioxide. Part A, hydrogen sulfide is the product of a reduction reaction. Let's find the oxidation state of sulfur in hydrogen sulfide. It is -2. In sulfuric acid we have 2 hydrogens, so it is +2 for hydrogen. Then we have sulfur. For 4 oxygen it will be -8, overall charge is 0. So sulfur is +6. Now sulfur changes from +6 to -2 as the oxidation state is reduced, so therefore this is a reduction reaction. Part B, iodide ions are stronger oxidizing agent than sulfate ions. Now iodide is -1 in sodium iodide, it is 0 in molecular form. Now from -1 to 0 is called oxidation. And the thing that is oxidized is called reducing agent. So iodide ions are stronger reducing agent than sulfate ions. This is wrong. Part C, sulfur atoms from the sulfuric acid are both oxidized and reduced. Sulfur is +6 in sulfuric acid. In sulfur it is 0, in H2S it is -2, in SO2 it is +4. Now we can see that sulfur goes from +6 to 0, which is reduction, +6 to -2, again this is reduction, +6 to +4, again this is reduction. For D, sulfur atoms from the sulfuric acid are oxidized to make sulfur dioxide. Now from +6 to +4 is reduction, it is not oxidation. Correct answer is therefore A. Question 18. NO, NO2, CO and unburnt hydrocarbons are present in the exhaust gases of internal combustion engines. When catalytic converters are used to remove these compounds from the exhaust gases, redox reaction occur. What happens to each compound in the catalytic converter? First one is NO, nitrogen monoxide. Now in catalytic converter, nitrogen monoxide reacts with carbon monoxide, and nitrogen monoxide is reduced to N2 while carbon monoxide is oxidized to CO2. So it is reduction of NO. Second thing is nitrogen dioxide. Nitrogen dioxide is reduced to nitrogen monoxide. So therefore this is also reduction. Now third one is carbon monoxide, and we can see that it has oxidized to CO2. Last thing is unburnt hydrocarbons. In unburnt hydrocarbons we have carbon and hydrogen. When they are combusted completely, carbon forms carbon dioxide and hydrogen forms water. So therefore this is oxidation. Correct answer is therefore C. Question 19. Methylamine CH3NH2 has similar chemical properties to ammonia. Methylamine reacts with hydrogen chloride to form white crystalline salt, methyl ammonium chloride. A sample of methyl ammonium chloride is heated with aqueous sodium hydroxide. What are the products? As the behavior is similar to ammonia, so for ammonia we can see that when it reacts with hydrochloric acid, it forms NH4Cl. Ammonium has positive charge while Cl has negative charge. Methylamine also gives similar type of product. Now second reaction is with aqueous sodium hydroxide. We know that ammonium salt upon reaction with sodium hydroxide, they always form salt, water along with ammonia gas. So methylamine should do the same. Now we are going to write the reaction for that. We have CH3NH3Cl. It reacts with aqueous sodium hydroxide. It will form salt NaCl. Then we have water. Now we have CH3NH2 that is left. So therefore that is the product which is formed. This is because in ammonium chloride, sodium reacted with chloride to form NaCl. One of the hydrogen reacted with OH to form water, and the remaining was NH3. Similarly, in this one we have sodium that reacts with Cl to form sodium chloride. One of the hydrogen reacts with OH to form water, and we have CH3NH2 that is left. So the product is sodium chloride, water, and methylamine. Correct answer is therefore D. Question 20. The structures of citric acid and isocitric acid are shown. This is citric acid and this is isocitric acid. How many chiral centers does each acid possess? Now chiral carbon is that carbon which is connected to 4 different elements or groups. Let's draw the structure of citric acid openly. We have first carbon having 2 hydrogens. Then we have carboxylic acid functional group. On second carbon we have OH and carboxylic acid functional group. OH on one side, carboxylic acid on the other. On third carbon we have 2 hydrogen and carboxylic acid functional group. With this carbon we can see 2 similar atoms are present, so therefore this is not chiral. With this carbon double bond is present, so this is not chiral. None of the carbonyl carbon is chiral. On this carbon we can see we have OH functional group, carboxylic acid functional group, but this group and this one is similar, so therefore this carbon is also not chiral. Similarly, this carbon is not chiral, so therefore there are 0 chiral centers in citric acid. Now let's draw isocitric acid. For first carbon we have 2 hydrogens, then carboxylic acid functional group. On second carbon we have 1 hydrogen and 1 carboxylic acid functional group. On third carbon we have hydrogen, OH and carboxylic acid functional group. Now first carbon is having similar atoms, so therefore this is not chiral. None of the carbonyl carbon is chiral. On this carbon we can see we have hydrogen, carboxylic acid functional group. This group and this group are different, so therefore this carbon is chiral. Now with the last carbon we can see we have 1 hydrogen, 1 OH, 1 carboxylic acid group, and this is the fourth group that is attached. As all 4 are different, so therefore this carbon is also chiral. So we have 2 chiral centers in isocitric acid. Answer is therefore D. Question 21. How many tertiary alcohols have the molecular formula C6H14O? Tertiary alcohols are such alcohols in which OH functional group is attached with tertiary carbon. Now tertiary carbon is that carbon which is directly attached to at least 3 carbon atoms. Let's draw tertiary alcohols having molecular formula C6H14O. We can have 5 carbon atoms in the long chain. OH functional group is present, and this carbon is directly attached with 3 carbon atoms. Now this is tertiary alcohol. Rest are the number of hydrogen atoms. Molecular formula is C6H14 and we have 1 oxygen atom. For naming we are going to start numbering from this carbon atom as OH functional group is nearer. We have 5 carbon atoms in the long chain. On second carbon we have alcohol functional group. We also have methyl group. So it is 2-methyl pentane, and OH is on second carbon, so it is 2-ol. Now we can shift the position of this OH to third carbon. The structure will be like this. As this carbon is tertiary carbon, so therefore it is attached to 3 carbon atoms directly. Rest are the hydrogen atoms. Molecular formula is again C6H14O. And the naming can be started from either end. It will be 3-hydroxy pentane. Then we have on third carbon atom methyl group. So 3-methyl pentane 3-ol. Another possible structure can be drawn if we move this carbon to this carbon atom. Let's draw this structure. We have 4 carbon atoms in the long chain. General formula is still C6H14O. And we can do the naming. OH functional group is nearer to this carbon, so it will be 4 carbon chain. Now the name is 2,3-dimethyl. Then we have long chain of 4 carbon, so it is butane. And on second carbon we have alcohol, it is 2-ol. These 3 are the only possible structures for tertiary alcohol, so therefore answer is C. Question 22. The diagram shows the structure of a bromo compound that may be formed by the reaction of bromine with a hydrocarbon. Which row is correct? We have to find out the type of reaction and the mechanism behind that reaction. As we can see that Br has replaced one of the hydrogen atoms of CH3. Again, this Br has also replaced one of the hydrogen atoms in CH3. So this is substitution. Another thing is that we can see that these bromine atoms are not present on adjacent carbon atoms, and this carbon does not have any hydrogen, so therefore it means it was not alkene. So type of reaction is not addition, it is substitution. Second thing is the mechanism involved in this substitution. As we can see that the reactant was alkane. So as in alkane, the electronegativity difference between carbon and hydrogen is not much to make up partial charges. So therefore this is not nucleophilic mechanism, it is free radical substitution. In free radical substitution, bromine radical will replace one of the hydrogen atoms to form CH2Br from CH3. For example, in CH4, the reaction can occur like this. We have free radical substitution. Now it will become CH3 radical along with HBr. Now CH3 radical can also react with bromine radical to form CH3Br. This is substitution because bromine has replaced one of the hydrogen atoms in the product. Correct answer is therefore D. Question 23. Part of the structure of strobilurin is shown. R and R prime are inert groups. This is a structure. Strobilurin is warmed with aqueous sulfuric acid, producing compound X. Compound X is then treated with hydrogen in the presence of nickel catalyst, producing compound Y. What could be the structure of compound Y? In the given structure, we have ester functional group that is present. We also have alkene functional groups that are present. Now aqueous sulfuric acid, it causes acid hydrolysis of esters. And after hydrolysis, carboxylic acid and alcohol is formed. There is no effect on the alkene functional group, so only this group will be changed. We can draw the structure. After acid hydrolysis, the carbonyl carbon will become carboxylic acid and CH3 will become alcohol. So this is methanol and this part will become carboxylic acid. Now this is compound X that is formed. And then compound X is treated with hydrogen. Hydrogen will be added in double bond to make it single covalent bond. In the presence of nickel catalyst, alkene is converted into alkane. So as this carbon atom has become carboxylic acid, this is true. And all alkenes are converted into alkanes. This is the correct structure of compound Y. In B, we can see that the carbonyl carbon has converted into alcohol, which is not possible, so therefore B is incorrect. In C, again we can see that compound X is alcohol. This is also incorrect because the carbonyl carbon always converts into carboxylic acid. It does not convert into alcohol. In D, this is correct as carboxylic acid is formed from carbonyl carbon. But alkene has been converted into diol, which is not possible. It is only possible when cold dilute KMnO4 is used. So option D is also wrong. Correct answer is therefore A. Question 24. Which compound produces a ketone when refluxed with an acidified solution of potassium dichromate 6? Now this is oxidizing agent. And ketone is formed by the oxidation of secondary alcohol. Primary alcohol is oxidized to aldehyde and further to carboxylic acid, while secondary alcohol is oxidized only to a ketone. Let's find out which one is primary and which one is secondary alcohol. In short, you can always see through this that whenever it is 1-ol, it means it is primary alcohol. Whenever it is 2-ol, it can be primary or secondary alcohol. Let's draw the structures. First one is pentane 1-ol. In pentane, we have 5 carbon atoms and single bonds. 1-ol means that OH functional group is present on first carbon atom. Now this is primary alcohol because this carbon is attached directly to just one carbon atom. So this will be oxidized in the presence of acidified solution of potassium dichromate to carboxylic acid, so it will form 5-carbon carboxylic acid. Similarly, second one is also primary alcohol as it is 1-ol. So we have butane in the long chain, so therefore we have 4 carbon atoms, and on second carbon methyl group is attached. Also on first carbon atom alcohol is attached. So as this is primary alcohol, because this carbon is attached to only one carbon atom directly, so it is oxidized to carboxylic acid. Third one is 2-methyl butane 2-ol. We have 4 carbon atoms as it is butane. On second carbon we have methyl group, and on second carbon we also have alcohol functional group. Now we can see that in this structure OH is attached to this carbon atom, which is directly attached with 3 other carbon atoms, so therefore this is tertiary alcohol. And tertiary alcohol cannot be further oxidized because this carbon does not have any hydrogen atoms attached to it. Last one is 3-methyl butane 2-ol. Again we have 4 carbon atoms in the long chain as it is butane. On third carbon we have methyl group. On second carbon we have alcohol functional group. Now the carbon attached with OH is further attached to 2 carbon atoms directly, so therefore this is secondary alcohol and it is oxidized to ketone. The carbon having OH group is converted into carbonyl carbon while the other structure remains same. The name would be 3-methyl, as we have 4 carbon atoms in the long chain, so it is butane 2-ol. Now this is the ketone that is formed by the oxidation of this alcohol, so therefore D is the correct answer. Question 25. Dibromopentanes can undergo double elimination reactions to produce hydrocarbons. which isomer produces only one hydrocarbon product. Double elimination means elimination that occurs 2 times. As we can see, in this structure we had 10 hydrogen atoms, 2 bromine atoms. Now in this structure we only have 8 hydrogens, so 2 hydrogen atoms are lost and 2 bromine atoms are lost. In single elimination, 1 hydrogen and 1 Br is removed. Hydrogen forms water and Br will form sodium bromide. In double elimination, 2 hydrogen atoms and 2 bromine atoms will be removed to form 2 sodium bromide and 2 water molecules. Let's do double elimination in these structures. First one is 1,5-dibromopentane. In pentane we have 5 carbon atoms in the long chain. On first and fifth carbon we have 2 bromine atoms, so this is 1 bromine, and on fifth carbon this is second bromine. Now bromine is eliminated along with the adjacent hydrogen atom present on adjacent carbon. Similarly, this bromine will be removed along with this hydrogen atom. In the presence of sodium hydroxide, sodium will form NaBr along with these 2 Br, so it will be 2 sodium bromide, and these 2 hydrogen will be removed to form 2 water molecules. Whenever elimination takes place, single bond is converted into double bond, as these 2 carbon atoms are involved in elimination and these 2, so therefore one double bond will come between these 2 carbon atoms and one double bond between these 2. So the product will be C double bond C, then we have single bonds, then again double bond C. Rest are the hydrogen atoms. The molecular formula is C5H8. This is the only hydrocarbon product that is formed, so therefore A could be correct option. In B we have 1,4-dibromopentane. Again we can draw pentane having 5 carbon atoms in the long chain. On first carbon and fourth carbon atom we have bromine. From adjacent carbon hydrogen will be removed and elimination will take place. Now from this carbon bromine is removed and from this carbon hydrogen will be removed, so there will be a double bond between these 2 carbon atoms. While this carbon has 2 adjacent carbon atoms having hydrogen, so either it could be eliminated from this carbon or hydrogen could be eliminated from this carbon atom. So double bond can either come between these 2 carbons or between these 2. Let's draw the product. We have sodium hydroxide. Now there are 2 possible products. In first one this double bond is present. Then we have 3 carbon atoms. Now if this hydrogen is removed along with this Br, then double bond will come between these 2 and this will be the product. If this hydrogen atom is removed along with this Br, then the product will be like this. Rest are the hydrogen atoms. In first hydrocarbon product we have double bond on first and third carbon atom, while in second hydrocarbon product the double bond is on first and fourth carbon. Other product is NaBr and H2O. Now as we can see that 2 hydrocarbon products are formed, so therefore B is incorrect. Let's look into the third one. We have 2,3-dibromopentane. In pentane we have 5 carbon atoms. On second and third carbon we have 2 bromine atoms, so this is second carbon and this is third carbon. Now elimination can take place in such a way that this hydrogen is removed along with this bromine. So second elimination will be possible if this hydrogen atom is removed along with this bromine atom. We can also see that this carbon has hydrogen atom present, so this bromine can also be eliminated with this hydrogen. So the second double bond can either be between these 2 carbon atoms or between these 2 carbon atoms. The possible products will be like this. We have double bond between first 2 carbon atoms, and then if this hydrogen is removed along with this Br, then double bond is present between these 2. And if this hydrogen is removed along with this Br, then we have this structure as product. Rest are the hydrogen atoms. As we can see that the double bond is present on first and second carbon, and in this structure double bond is present on first and third carbon, so therefore both hydrocarbons are different. So as two hydrocarbon products are formed, C is also wrong. Last one is 2,4-dibromopentane. Again we have 5 carbon atoms. On second carbon and fourth carbon we have bromine. Again, elimination can take place in such a way that one hydrogen atom is removed from adjacent carbon. Second double bond can either come between these two carbon atoms if this hydrogen is removed along with Br, or between these two carbon atoms if this hydrogen is removed along with this Br. The possible products will be like this. In first product we have double bond between first two carbon atoms as these two are removed, and another double bond between these two carbon atoms as this is removed along with this bromine. Now in second possible product, first double bond will be at the same place, while second double bond will be between these two carbon atoms as this hydrogen is removed along with this Br. Rest are the hydrogen atoms. In the first product, double bond is between first two carbon and then third and fourth. In second product, double bond is between first two carbon and fourth and fifth. Two hydrocarbon products are formed. This is also incorrect. Only correct option is A. Question 26. The diagram shows the formation of compound Y from compound X in a chemical reaction. R1 and R2 are alkyl groups. We can see that X reacts with hydrogen cyanide in the presence of potassium cyanide to form hydroxynitrile. Which row about this reaction is correct? We have to find out the mechanism and structure of compound X. Now OH and Cn is attached to always carbonyl carbon, and this carbonyl carbon is directly attached to two alkyl groups, so therefore this is ketone. We have R1, then carbonyl carbon, then R2. Potassium cyanide provides cyanide nucleophile. It will attack partial positive carbon atom, and this double bond is converted into single bond. The product formed is like this. We have R1, then carbon, Cn is attached to this carbon atom. Now double bond has converted into single bond and oxygen become negatively charged. It also has lone pair of electrons. Now this oxygen will attack this hydrogen present in HCN. This bond is broken, and the product formed is R1, carbon, R2, oxygen converts into OH, and then we have Cn. This Cn is removed in the form of nucleophile. As we can see that nucleophile was involved in this reaction and addition has taken place on carbonyl carbon, so therefore this is nucleophilic addition, and compound X was ketone as it is attached to two alkyl groups. Correct answer is therefore C. Question 27. In this question you can assume that H1, which is protium, and H3, which is tritium, have the same chemical properties as both are the isotope of hydrogen. A sample of ethanol contains only one isotope of hydrogen, which is protium. It is reduced to compound Z in a nucleophilic addition reaction using NaBH4, which is reducing agent. All the hydrogen atoms in NaBH4 are tritium isotope. This is the reaction. Aldehyde is converted into compound Z. Upon reduction, aldehyde converts into alcohol. Then compound Z is then oxidized back to ethanol and water. Then oxidation of primary alcohol takes place and it converts back into aldehyde functional group and water. Which statement about the final mixture of products is correct? Now we have to find out whether which product consists of tritium isotope of hydrogen. In the start we had ethanol. Let's draw ethanol. Ethanol consists of 2 carbon atoms, and as it is aldehyde, so carbon is present. Now this sample of ethanol contains only one isotope of hydrogen, so all are protium isotope of hydrogen. Now it is reduced in the presence of NaBH4 to compound Z, which is alcohol, and NaBH4 consists of tritium isotope. So we have reduction. After reduction, the product will be like this. We have primary alcohol that is formed. These are the hydrogen atoms that were already present on the molecule, so all are protium isotope. Now upon reduction, one hydrogen atom is attached to this oxygen, which is tritium isotope, and one hydrogen is attached to this carbon, which is tritium isotope. Now this is primary alcohol called ethanol. Now this ethanol is oxidized back to ethanol and water in the presence of oxidizing agent. Now water is formed as one of the product and aldehyde as the other one. The product will be like this. We have CH3. Then with this carbon we only have oxygen as it has converted into aldehyde. So this hydrogen atom is lost to form water. Now along with this hydrogen atom, another hydrogen atom could be this one or this one, as both are equivalent, so anyone can form water. If this hydrogen atom is removed along with this one, then the product will be like this. We have H1, then we have oxygen, and then we have H3. So aldehyde would have this hydrogen left. In the second possible structure of aldehyde, we have CH3, then carbonyl carbon, and if this hydrogen atom is removed along with this one to form water, water would be like this. We have oxygen and tritium hydrogen to form water. This hydrogen will be left along with this carbon. Now in the final mixture of products, we can see we have these 4 products that could be formed, and aldehyde and water both consist of tritium hydrogen atoms. Correct answer is therefore A. Question 28. Ethane dioic acid has the formula. We have 2 carboxylic acid functional groups that are present. What is the formula of aluminum ethane dioate? As in carboxylic acid, hydrogen is +1 oxidation state, and we have 2 hydrogen atoms that could be removed, so there is -1 on this side and -1 on this side. So for ethane dioate, the total charge is -2. We can also write it as C2O4 -2. Aluminum is in group 3 of the periodic table, so the oxidation state is +3. In formation of compound, oxidation state is converted into numbers. So the product formed will be Al2 C2O4 3. Correct answer is D. Question 29. Which reaction gives butanoic acid as one of its products? In all A, B, C and D we have esters. First one is butyl ethanoate and then we have ethyl butanoate. Now butyl ethanoate structure is like this. We have 2 carbon atom carboxylic acid, so 2 carbon atom are present with carbonyl carbon. Then we have butyl, which means we have 4 carbon alcohol that was present in the reactants. So this is the structure of butyl ethanoate. Rest are the hydrogen atoms. Upon acid hydrolysis, carbonyl carbon is converted into carboxylic acid while this other part is converted into alcohol. So we have ethanoic acid as carboxylic acid and butanol as the other product. Upon alkaline hydrolysis, this carboxylic acid hydrogen is replaced with sodium if it is sodium hydroxide alkali that is present. The other structure is the same. So we have sodium salt of carboxylic acid, which is ethanoic acid, along with the same butanol. So we have ethanoic acid and sodium ethanoate, so therefore A and B are incorrect. Now second ester is ethyl butanoate. Butanoate means we have 4 carbon atoms present with carbonyl and 2 carbon with alcohol. Rest are the hydrogen atoms. Again, upon acid hydrolysis, this part will become carboxylic acid and this part will become alcohol. So the structure would be like this. We have CH3, CH2, CH2, COOH. This is 4 carbon carboxylic acid, so therefore this is butanoic acid. And second part is alcohol. We have 2 carbon alcohol that is formed, which is ethanol. Again, if it was alkaline hydrolysis, for example sodium hydroxide was used in hydrolysis, so this carboxylic acid hydrogen would be replaced by sodium. So this product was sodium butanoate along with the same alcohol that is produced. So as C produces butanoic acid as one of the products, therefore this is the correct answer. Question 30. When reactant X is treated with suitable reagent, products Y and Z are formed. Infrared spectra of X, Y and Z are shown. This is reactant X. From the given spectra, we can assume that as carbonyl peak is absent, that was between 1670 to 1730, strong and sharp peak. And we can also see that broad peak between 2500 to 3000 is also absent, which was due to alcohol functional group. So alcohol is also absent. So if carbonyl is absent, then it is not aldehyde, nor ketone, neither carboxylic acid, nor ester. And as OH is also absent, so therefore this is also not alcohol. This is product Y and this is product Z. From the given spectra, we can see that now carbonyl peak is present at around 1700 something. And around 2500 to 3000 broad peak is absent, so therefore OH is absent. So if carbonyl is present and OH is absent, it means it is not carboxylic acid. It can be aldehyde or ketone or ester. It is not alcohol as OH is absent and carbonyl is present. In the last structure, we can see that carbonyl peak is present. Broad OH peak is also present. So as both carbonyl and OH peak are present, so therefore this is the structure of carboxylic acid. As in carboxylic acid we have C double bond O, we also have OH. So according to infrared spectra of X, it is neither aldehyde, ketone, carboxylic acid or ester. So therefore we can see that this one is absent, so it could either be pentoene or this is also alkene and this is also alkene. Now in product Y we have seen that carbonyl was present while OH was absent, so therefore it is not ethanoic acid. It could be ketone, that is propanone. In structure Z we had carbonyl as well as OH, so therefore this is carboxylic acid, so it should be propanoic acid. Correct answer is therefore B. Question 31. A sample of 17.15 moles HI gas is in dynamic equilibrium with 2.27 moles hydrogen gas and 2.84 moles of iodine gas in a volume of 1 meter cube at 764 kelvins and 141 kilopascals. This is the equilibrium reaction. Two equilibrium constants, one is Kc and one is Kp, can be calculated for this mixture. Which statement about the equilibrium constants for this mixture are correct? In first one we have to find out the units, in second one we have to find out the Kc, and third one we have to find out Kc and Kp. Let's first find out the value of Kc. For Kc the formula is the concentration of product, which is Hi raised to the power its number of moles, which is 2, divided by the product of concentration of reactants, which is hydrogen, and second one is iodine. Now the unit of concentration is mole per decimeter cube, so we can write mole per dm cube square divided by mole per dm cube for hydrogen and mole per dm cube for iodine. As this will cancel out, so therefore there are no units for this Kc value. For finding the concentration we need number of moles and volume in decimeter cube. Number of moles is given. Volume in decimeter cube can be converted from this value. We have 1 meter cube, so therefore it will be equal to 1000 decimeter cube. Now concentration will be number of moles divided by volume. As it is 1000 decimeter cube, so therefore concentration for Hi would be 17.15 divided by 1000, so therefore it will be exponential minus 3 mole per decimeter cube squared. Divided by the concentration of hydrogen, which is 2.27 moles divided by 1000 decimeter cube, so it is 2.27 exponential minus 3 mole per decimeter cube. Again for iodine it is 2.84 exponential minus 3 mole per decimeter cube. By solving this one we have Kc equals to 0.000294122 divided by these values, which is 0.645. Now value for Kc come equal to 45.6. So statement 2 is correct. Second one is Kp. For Kp the formula is partial pressure of product, which is hydrogen iodide, so it will be the pressure of Hi. As there are 2 moles, so it will be squared divided by the partial pressure of hydrogen into the partial pressure of iodine. We can find the pressure for each gas by using this volume, temperature and pressure and number of moles. So this can all come into the ideal gas equation, which is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is ideal gas constant, and T is the temperature. So we can find pressure, P is equal to number of moles into R into T divided by volume. As volume given is 1 meter cube, so therefore we can write this equation as pressure is equal to nRT, where N is the number of moles, R is ideal gas constant, and T is temperature in Kelvin. Now let's find the partial pressure of each gas. We have hydrogen iodide, hydrogen and iodine. So first one is hydrogen iodide. Number of moles is 17.15. R is 8.314. Temperature is given, it is 764. It comes equal to 10882.60 Pascal. Similarly, we can find the pressure for hydrogen. Rest of the values are same, only number of moles is changed, which is 2.27. It comes equal to 14411.8668 pascals. Similarly, for third one, which is iodine, the number of moles is 2.84. It comes equal to 18030.70 pascals. Putting all these three values in this equation, we have Kp. It is equal to pressure of hydrogen iodide square divided by the pressure of hydrogen into the pressure of iodine The value for Kp comes equal to 45.6. So we can see that third one is incorrect because both values are same. Now about the units. The unit for partial pressure is Pascal. So hydrogen iodide will be Pascal square divided by the pressure of hydrogen, which is pascals, into pressure of iodine, which is also pascals. So there are no units left. So neither Kc nor Kp has any unit. This is correct. As option 1 and 2 are correct, answer is therefore B. Question 32. An energy cycle for the combustion of methane is shown. This is the triangle. We have methane. It combusts in the presence of oxygen to form carbon dioxide and water. These are the elements that are present. Which expressions can be used to calculate the energy change delta Hz? This is delta Hz that has to be calculated. In first one, we have enthalpy change of formation of CH4 plus enthalpy change of combustion of CH4. As we can see that these are the elements, and elements first convert into the reactants and then reactants convert into the products. So therefore this is a two-step process, and this is direct process in which elements directly convert into the products. So according to Hess's law, two step is equal to one step. So therefore delta Hz will be equal to enthalpy change of formation of CH4. As we only have 1 moles of CH4, so therefore only one value is required. And then we have enthalpy change of combustion of CH4, as 1 mole of CH4 is combusted to form products. So therefore first expression is correct. In second expression, we have enthalpy change of combustion of carbon solid, which is this one, and enthalpy change of combustion of hydrogen multiplied by 2, which is this one. As we can see, the elements can directly convert into this product, and that will be the enthalpy change denoted by delta Hz. As we have 1 mole of carbon, so therefore it is just one value, and we have 2 moles of hydrogen, so it is multiplied by 2, so therefore statement 2 is also correct. For third one, we can see that we have enthalpy change of combustion of carbon monoxide and enthalpy change of combustion of hydrogen multiplied by 2. As we do not have carbon monoxide in either of this cycle, so therefore this expression is wrong. Option 1 and 2 are correct. Answer is therefore B. Question 33. Many gases do not obey the general gas equation at high pressures. Why is this? Number 1. At higher pressure, the molecules have more energy. This is incorrect, because pressure does not provide energy, only temperature provides kinetic energy to molecules. Second, at higher pressure, the volume of molecule is larger proportion of the total volume. Now, according to general gas equation or ideal gas equation, the volume of molecules is negligible as compared to total volume. So when higher pressure is applied, the molecules come close together, so therefore the volume of molecules become quite significant. So this statement is true. Third one, at higher pressure, the molecules experience greater intermolecular forces. Also, we know that according to ideal gas equation, there are no forces of attraction or repulsion between molecules. So as at higher pressure, the molecules experience greater intermolecular forces because the molecules come close together and IMF is developed. So therefore, this is why gases do not obey the general gas equation. As option 2 and 3 are correct, answer is therefore C. Question 34. Which species can accept a lone pair of electrons to form a coordinate or dative covalent bond? Now, those compounds can accept a lone pair which are electron deficient. Electron deficient means that the central atom does not have complete 8 electrons in its outermost shell. First one is BF3. Now, boron has 3 electrons in the outermost shell that are bonded to 3 fluorine atoms. Now still we can see that only 6 electrons are present in the outer shell of boron, so therefore it can accept a lone pair of electrons to complete its octet. So therefore BF3 can make a coordinate or dative covalent bond. For example, we have NH3, BF3, in which this nitrogen provides its lone pair to boron to complete its outer shell. Second is H+. Now H+ is electron deficient because it has 0 electrons and it will need 2 electrons to complete its first shell. So it can take electron such as ammonia can give its electron pair to form NH4+. So therefore this will make a coordinate covalent bond. Third one is CH3 positive. In this structure we have deficiency of electrons. Carbon only has 3 electrons in the outermost shell that are bonded to 3 other hydrogen atoms, and there is positive charge, which means that 1 electron is lost. So now carbon has 6 electrons in the outermost shell, so it can gain a lone pair of electron to form coordinate covalent bond. As all 3 options are correct, answer is therefore A. Question 35. A sample containing X moles of aluminum chloride is dissolved in water to give solution W. In order to precipitate all of aluminum as its hydroxide, Y moles of sodium hydroxide are required. More of the alkali is added to redissolve the precipitate, giving solution Z, which statements are correct. Now X moles of aluminum chloride is dissolved in water to give solution W. We can write this as Al2Cl6. When it is dissolved in water, it forms aluminum plus 3 and chloride minus 1. Now what happens with aluminum plus 3 is that it is surrounded by water molecules. Aluminum is surrounded by 6 water molecules. Overall charge is plus 3 of this complex ion. Now proton is lost from one of the water. So now we have AlH2O5. One of the water molecule has lost H+, so then OH is left behind. And the charge now becomes plus 2 along with H positive ion. Now this produces H positive ion, which means the solution will now become acidic. This is solution W. Number 1, the initial pH of solution W is below 7. As we can see that the solution is acidic, so the pH must be below 7, so statement 1 is true. Second thing is the dissolution of precipitate of aluminum by adding sodium hydroxide. So we can write the chemical equation. Aluminum chloride plus sodium hydroxide. It forms aluminum hydroxide along with sodium chloride. Let's balance this equation. We have 2 aluminum atoms on the right hand side, so we can balance 2. We have 6 chlorine atoms, so we can write 6 with NaCl. Now we have 6 sodium, so we can write 6 with Na. Oxygen and hydrogen are already balanced. Now in balanced equation, we have 1 mole of aluminum chloride, which is X. So X equals 1. We have 6 moles of sodium hydroxide, which is Y. So Y equals 6 moles. So we can say that 2 is wrong because 6 does not equal to 3 into 1. Part 3, Z contains X moles of aluminum. Now solution Z is formed by adding alkali to dissolve the precipitate. This is the precipitate that is dissolved in excess alkali. In this precipitate we have 2 moles of aluminum. So Z is equal to 2. When it is compared with X, it is not equal to X as X is 1. So Z is equal to 2 into X. C does not contain X moles, it contains 2 X moles of aluminum. As only option 1 is correct, the answer is D. Question 36. Nitrogen dioxide gas is produced when petrol is burned in car engines. Which acids are made in the atmosphere as a result of this release of nitrogen dioxide into the air? First one is H2SO3. This acid can be formed by the sulfur dioxide that is present. When it combines with H2O, it forms H2SO3. So 1 is incorrect. Second is H2SO4. Now nitrogen dioxide that is released, it can react with sulfur dioxide. In this chemical reaction, it can form sulfur trioxide along with nitrogen monoxide. Now this sulfur trioxide can dissolve in water, which is rain, to form sulfuric acid. So nitrogen dioxide can make sulfuric acid, so this is correct. Third one is nitric acid. NO2 can also react with water to form HNO2 and HNO3. So this is also correct. As option 2 and 3 is correct, answer is C. Question 37. In which reactions is the major product formed by a nucleophilic substitution reaction? We have bromoethane and potassium cyanide, ammonia and hot concentrated sodium hydroxide in ethanol. Let's look into the first reaction. We have bromoethane. Ethane is the one having 2 carbon atoms, and bromine is also present, plus potassium cyanide. Now KCN can provide cyanide nucleophile. This nucleophile will attack partial positive carbon, and this Br is eliminated. So this is called nucleophilic substitution because Cn negative is a nucleophile. The product formed will be Cn plus Kbr. As this product is formed by nucleophilic substitution, so therefore this one is correct. Again, in second we have bromoethane, 2 carbon atoms and bromine, plus ammonia. We have ethanolic ammonia. Now ammonia is also a nucleophile as it has a lone pair of electrons. It will provide its lone pair to partial positive carbon atom, and this bond will be broken. So the product formed is, we have 2 carbon atoms, then we have NH2 and HBr is lost. Again we can see that this is nucleophilic substitution as Br is substituted by NH2. So option 2 is also correct. In third one we have bromoethane and hot concentrated sodium hydroxide and ethanol. This will cause elimination reaction. On one carbon we have bromine, on second carbon hydrogen will be eliminated. The product formed will be alkene, and it will form NaBr and H2O. So this is not a nucleophilic substitution reaction, this is elimination reaction. So third is incorrect. As first 2 options are correct, answer is B. Question 38. An excess of P reacts with Q in the presence of concentrated sulfuric acid to form R. Effervescence is seen when a piece of sodium is added to pure R. The structure of P is this. We have carboxylic acid functional group. We also have alcohol functional group. Which organic compounds could be compound Q? We can write structural formula for this. Skeletal formula we have CH3. Then this carbon atom, then we have CH3, OH, then we have CH2 and COOH. First one is carboxylic acid, we have CH3, C double bond O, OH. Now P can react with this Q. As we have alcohol functional group, we have carboxylic acid functional group to form ester. Product will be like this. We have this structure. Now this carbon will react with oxygen and water molecule is eliminated. This is the rest of the part. In this way ester is formed. Now in this ester we have ester functional group. We also have this carboxylic acid functional group that is present. Now this carboxylic acid can react with sodium metal to form salt along with hydrogen gas, and effervescence is seen when sodium is added to pure R, so therefore 1 is correct. Second one is ethanol. We have CH3, CH2, OH. It can also react with the carboxylic acid part to form ester. The product will be like this. We have CH3, CH3, OH, then we have CH2, then this carbonyl carbon, then we have this oxygen and these two carbon atoms. Now we can see that in this structure we have ester functional group, we also have alcohol functional group. Now alcohol functional group can react with sodium metal to form alk oxide and hydrogen gas is released. So 2 is also correct. Third one is ketone. We have CH3, then carbonyl carbon, then again CH3. Now ketone does not react with carboxylic acid or alcohol, so therefore 3 is incorrect. As option 1 and 2 is correct, answer is B. Question 39. Two carbonyl compounds have the molecular formula C3H6O. Which reagents give different observations with these two compounds? Now carbonyl compounds means that we have carbonyl carbon present, which is C double bond O. It can be aldehyde or ketone. Now 3 carbon aldehyde is like this. We have CH3, CH2, C double bond O, H. The molecular formula is C3H6O. We can also draw ketone. We have CH3, C double bond O, CH3. Again we have the same molecular formula as this one. First one is acidified aqueous potassium manganate 7. This is oxidizing agent. It will oxidize aldehyde to carboxylic acid, CH3, CH2, COOH, but it cannot oxidize ketone. Itself it will convert from purple to colorless when it is oxidizing aldehyde. So therefore this will give different observations. Second is Phelan's reagent. In Phelan's reagent copper plus 2 is present, which is reduced to copper plus 1 upon reaction with aldehyde. It does not react with ketone, so therefore this will give positive result with aldehyde but not with ketone. So this is also correct. The color will change from blue to red upon reaction with aldehyde. Third one is alkaline aqueous iodine. Now alkaline aqueous iodine gives triiodoform test. This is only positive for those carbonyl compounds that have CH3 directly attached with the carbonyl carbon. As we can see that in aldehyde there is no CH3 directly attached with carbonyl carbon, but in ketone we have CH3 attached. So therefore this will give positive result with ketone but not with this aldehyde. Yellow precipitate is formed. This will be with this ketone. All 3 options are correct. Answer is A. Question 40. An organic compound T does not phase when aqueous sodium carbonate is added to it. Compound T contains this much percentage by mass of oxygen. What could be the identity of T? First one is propanol. Propanol is aldehyde. We have 3 carbon atoms, CH3, CH2, CHO. Propanol does not react with sodium carbonate to form any gas. Now let's find out the molecular mass of this compound. We have 3 carbon atoms, so it will be 36. Plus we have 6 hydrogen atoms, 1 oxygen atom. Molecular mass comes equal to 58. Let's find the percentage of oxygen. Percentage of oxygen is equal to atomic mass of oxygen, which is 16, into its number of atoms in the compound, which is only 1, divided by the molecular mass of compound into 100. So the percentage come equal to 27.6%. Option 1 is correct. Second is ethyl butanoate. This is ester. We have 4 carbon carboxylic acid part. And 2 carbon alcohol part. Ester does not react with sodium carbonate. Now let's find the molecular mass of this one. We have 6 carbon atoms, so it is 72, plus we have 12 hydrogen atoms and 2 oxygens. So the molecular mass comes equal to 116. Let's find the percentage of oxygen. Atomic mass of oxygen is 16. Number of atoms in this compound is 2. Molecular mass of this compound is 116 into 100. So it comes equal to 27.6%. Option 2 is also correct. Third one is 3-methyl pentanoic acid. This is carboxylic acid. We have 5 carbon atoms. On third carbon atom we have methyl group attached. Rest are the hydrogen atoms. Now carboxylic acid can react with sodium carbonate in acid-carbonate reaction to form salt along with carbon dioxide and water. Therefore, this is incorrect. As option 1 and 2 are correct, answer is B.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.